can see there my introduction. This is the one I'm most proud of. I don't know if that translates into Hebrew. An old geezer, is that, does that you get the, okay. It's a real privilege to be here. When I was asked, I said yes immediately because I love coming to Tel Aviv. We have a development facility here at Tel Aviv. And I've enjoyed great memories over the years and impressed with this area and your development abilities and achievements, especially in storage. All right, just amazes me whenever I hear of a small company in storage. It has a good chance that it has an Israeli background. So it is an honor. I have that introduction. I realize is a little old. I've been with IBM for 38 years now and been in storage development for that entire time. And I've seen a great amount of change, as many of you with balding hairlines and gray hair can attest to. I remember when I first started with IBM, started in Rochester, Minnesota on the IBM System I. It was called the System 38 at the time. And I remember being shown this large computer that I was going to be working on. And they said, Andy, that over there is a 3370 disk drive. I said, wow. It has 572 megabytes in it. I said, no. What could you ever do with 572 megabytes? And now, 38 years later, we're 1 million times denser than that and still growing. And we figured out what to do with it. Isn't that amazing? So what I'm going to do is share with you some trends from an interesting perspective. I am a deep technologist, but I spend about 1/3 of my time with customers, all right? And I do that helping our sales team, but really the person that has helped the most is me. Because I learn really what they need and where the industry needs to go. And I don't just spend it with customer executives. I spend it with the admins. I spend it with the people who are going to have to manage it. And so I understand where they need to go, where they are desiring things that go. And so I'm going to talk about some of that. There are 4 basic trends that I really am focusing on inside IBM, and I believe these are the trends that most influence the storage industry. Storage industry here being storage for IT, storage for businesses, all right? And because we're in Israel, I'm going to start from the right. You go right to left, right, when you read, all right? So I'm going to start from the right because I actually think that is the most important thing, all right? Now, we talk a lot about AI, and Alex is going to talk about the importance of AI and what every technologist should know. I believe AI should be an important aspect, actually, of the storage. And what I mean by that is, storage is a very complicated entity. And supporting it, servicing it, figuring out the performance problems, figuring out my capacity, figuring out what I do is a very complicated thing. And storage admins are at a premium. They have to manage an ever-increasing amount of storage. And Flash, although it has simplified many aspects of the storage system, it has now shown weaknesses in the network. It stresses bottlenecks. It puts more stress on various parts of the ecosystem. Therefore, supporting it and figuring out what's wrong is complicated. So what we really need is to invest in AI in 3 different areas of storage. One is performance management. Finding out those performance problems and bottlenecks and what's causing those spikes to help our clients, all right? Can't tell you how many times I have tried to help customers with problems because at 2 in the morning when they're doing backup, the spike goes to 10 milliseconds. And it can take a long time to solve that. What we need is help in the in the system itself to develop what is wrong, to figure out what is wrong, and to even correct it if possible. So performance is a very important aspect of this. In IBM, we have a system called Storage Insights that runs in the cloud, and it collects data from all of the storage products around the world, all right? All those that allow the storage statistics to be collected. And by doing that, it's able to see trends. It's able to see problems that might be developing in a particular firmware load that it can therefore help in figuring out what is the problem or give advice for it. All right? The second area is related to performance, because performance is often the problem, but that is in terms of service and support, figuring out what is wrong or what is going to be wrong even before it happens. All right? One of the things we have in Storage Insights is a detector and corrector for something called slow drain. And slow drain is a problem that can develop slowly. It's a particular server that is causing the entire storage system to slow down. And so it's important to be able to detect that. For a human to do so is a very complicated thing. And so we've developed heuristics inside Storage Insights that can do that. That's just one example. I think this is an area rife for innovation. We often think about how important it is to develop new types of memory and storage and new types of interfaces and protocols, but developing the ability to support and service and find out what's wrong with our storage is an important area for us to look at as well. The second thing, and related to it, is what I call simple, simple, simple. All right? You know, one of the toughest things for deep technologists to do, and that is to develop products that are easy to use. All right? It's very difficult to take complex technologies and provide them to customers in a way that they can be easily consumed. Right? We often think of all the different options that we want to provide, all of the different choices that we may not know how they're going to be used, so we allow the end user to do that. And what that does is elevate the complexity of the decisions for that customer. And so where I think things are really going and need to go is this area of simple, simple, simple. The XIV product, the A9000 product that IBM had is a prime example of this because it makes the choices for you. And this is the direction for all of our storage products, our user interfaces. But more than that, the storage itself really needs to be self-configurable, self-monitoring, make the decisions and options without the user having to do so. Now, the area of differentiated flash is where I've spent the last 10 years, and that is an area that I'll spend quite a bit of time on. And in differentiated flash, in some ways, I could call that computational storage. All right. We've, inside IBM, developed our own flash controllers. We got the technology from Texas Memory Systems and have really taken that technology to a level that I'm very proud of, and we're continuing to do that. You see some of the interesting things here that I'll spend more time on. One of the things that we have done is to put compression inside that flash controller, all right? And therefore you can get data reduction at speed with no performance degradation whatsoever. It sounds simple to do. The difficulty is to, at a system level, be able to project what that capacity is and to be able to give accurate capacity reporting to the client when all of your flash drives are doing their own compression. All right. So I'll talk a little bit more about that. Another thing that in differentiated flash, I think we're going to have to change that from differentiated flash and storage class memories, is the ability to to have a storage system that can use storage class memories and flash in the same way we used to have flash and hard disk drives. Hybrid systems that can be sped up by storage class memories, use them as a fast tier, and flash as the secondary tier. Now, the one on the left is an interesting thing for deep technologists like us. Our products are ever more being used in a hybrid cloud environment. Inside IBM, our focus is on hybrid cloud and AI. And so it's very easy for storage developers to ask themselves, how do I fit into that hybrid cloud? And so I think the important thing is to understand that our appliances, our technology, our flash, our storage class memory are part of a hybrid cloud infrastructure, and that our appliances have to be able to be interconnected inside the cloud. To explain a little bit more about that, as we talk to clients, what we learn absolutely is that it's a hybrid multi-cloud world. As I talk to executives, as I talk to clients, yes, they have an on-premise storage device, an on-premise data center, but they have they often have at least 5 private and public clouds that they have to deal with. So you can imagine the requirement, therefore, is how do I connect those easily to manage them, but more than that, how do I interconnect and provide data storage and interconnectivity for the data, all right? 80% of the companies have moved applications or data from public cloud in 2018. So the way this journey started was that customer-facing applications moved to the cloud, all right? All of your iPhone applications are probably in the cloud, and the business-critical applications remained in the data center. That's starting to change as business-critical applications also are now starting to move to the cloud, or at least part of them. And so as that happens, as I have some of my storage on-premise, some of it in the cloud, I have to develop the easy way of being able to connect those together, to send data back and forth reliably, quickly, and to have common interfaces, common APIs, and to do it in a reliable and very fast way. And so hybrid and multi-cloud are becoming the new normal. So as I develop storage systems, as I'll talk about in a moment, our flash system 9100, what's important is how does it fit into a hybrid multi-cloud strategy? How can it be used as a building block? How can it be used as a technology that's part of this strategy? And so as we talk to clients, we find 6 different value drivers that are driving cloud adoption. I'm not going to speak to each one of these, but I'm going to pick out a few that you're probably aware of and that I think really need to underpin all of our storage technology, all of our devices. Number 1 is security. Can't emphasize enough how important this has become and will continue to become. There are nations out there that make it their business to try to figure out how to invade our computer systems and to hold for ransom our clients. And it is becoming ever more of a threat, and they are sophisticated. It is their business to do so. And therefore, we have to be thinking security in everything we do. For a long time, as storage developers, we left that responsibility to the servers and the applications and the networks. We would provide security for data at rest, but that would really be the extent of our responsibility. I challenge you to be thinking, how can we also have our storage systems as the last line of defense? For example, one of the things that that I often think about is, can the storage system detect a change in the data reduction level of the data coming in? To at least alert customers that, hey, you used to have 3-to-1 compressible data. I've noticed that it's now completely random data. It might be that somebody's encrypting your data, and it might be that it is an attacker. Now, maybe it's a change in the policy, and therefore there's no problem. That's an example of where we need to be thinking as we develop our protocols, develop our storage systems, that security is a vital requirement, and that it's not going to get better, it's going to get worse. All right? So security is a key, absolutely critical part. In terms of application modernization and cloud services, it's all about containers. And to make our storage container friendly, able to connect with servers that have containers running on them, and in many cases the storage systems themselves designed in a way that that can provide easy access to containers. So what are the storage challenges that we're facing? In the old days being a few years ago, all right, the key was to cut the infrastructure cost. So as clients would look at whether they need to be in the cloud, on-prem, it was often a matter of what's my budget and how do I cut my infrastructure costs. Really, the new challenge is storage connectivity. How do I take my on-premise device, that precious storage device that has in it flash, that has storage class memory, that I use for my critical applications, and how do I connect to the cloud perhaps for my disaster recovery? All right? I can't afford, or I don't want to afford, to have 2 instances of it. I want to be able to have my disaster recovery copy in the cloud. To do so, I have to have a way of connect to it and be able to send data at speed, reliably, and then to bring up that storage in the cloud fast enough that I can make use of it as a disaster recovery. That's one example. So storage connectivity is being critical to allow me choices. It's not just a matter of cutting costs anymore. It's a matter of allowing flexibility. Storage location has become more important than avoiding vendor lock-in. And the speed of adoption matters. Just think about for a moment, 5 years ago, and how things are so different now. So as we design our systems, we have to realize that in the next 5 years, there's going to be tremendous changes as well. And so we need to be designing standards that are flexible, storage devices that can easily modify to adapt to that change. One of the things that I was really excited about with the purchase of Red Hat for IBM is that it gives us an infrastructure, it gives us a set of building blocks that we can use to help our clients in a hybrid cloud with OpenShift and Red Hat OpenShift containers. Containers is one of those technologies that has really amazed me. Just think about 10 years ago. What was a container 10 years ago? It truly was the container on the ship that that took produce. 10 years ago, I don't think containers existed. Somebody can correct me if I'm wrong. At least they weren't talked about very often. And think now where containers are. They are ubiquitous in the cloud world, in the public cloud, and they provide a tremendous simplicity and tremendous flexibility and the ability to run lots of microservices and to do functions much easier and to change and upgrade code in a much more reliable and flexible way. And so we need to be thinking of that both in how we develop our storage systems and in how they're going to be used. And Red Hat and OpenShift is an exciting way that will provide us the capability to have the infrastructure in cloud providers and to use that in a variety of ways. Now, when I look at differentiated flash, this is one example. This is our flash system 9150. And the few things that I want to point out about this and use this as an illustration of where I think the industry is going for flash. I mentioned that when I first started with IBM, the product that I started on was a 3370 disk drive with 572 megabytes. This product here can hold 378 terabytes of flash in 2U, all right? Because it has compression built in, the effective capacity it can hold is about 870 terabytes, all right? That's with the hardware compression inside. With the software deduplication and compression, it can hold up to 1.8 petabytes. That's an amazing amount of capacity. Sometime in 2020, all right, I can't say exactly when, that will double. And you'll be able to have 1.7 petabytes in 2U, all right? That's without compression, by the way, all right? I'm sorry, that is with compression. 760 terabytes without and about 1.7 with. An amazing amount of capacity. Now, I want you to think of the challenges that brings with it, all right? I often talk to clients about how dense this storage device is, expecting them to be impressed, all right? Wow, that's 370 terabytes in 2U, 865 terabytes of effective storage. And often the way they respond to me is like a deer in the headlights, all right? It's like I have a horn growing out of my forehead. And the thoughts that they are having is, if something happens to that, my entire data center is essentially going down, all right? I'm exaggerating a little bit, but you get the point. What is becoming more critical than the density is the ability to recover when things go wrong. And as much as we design for things to not go wrong, they do. And so the emphasis in this product is not just the density, but the right mix of software and storage and storage services like asynchronous remote copy, HyperSwap, synchronous remote copy to allow for a backup and a restore online in case something happens. So it's not just the density, it is the ability to quickly recover when things go wrong. This device can hold up to 24 NVMe storage SSDs. We have developed those inside the 4.8, 9.6, and 19.2 terabyte NVMe SSDs. They have compression built in, and I'll talk a little bit more about that. We have designed it so that you can put in NVMe storage class memory, and that might be an Optane device, it could be a Samsung low latency NAND. That will come sometime later. It is enabled to do that. So I want to talk a little bit about where I think storage systems, how are they going to use both flash and storage class memories, all right? As much as I love storage class memories, the economics do not usually allow them to be the entire storage system. It is unaffordable. Now, where we're looking at implementing storage class memories is as a tier. And so you could have 2 or 4 of these 2.5-inch Optane devices or Samsung low latency NAND, and they can be a tier for the storage system, and we will figure out the hot data that goes on them. And so the interesting thing we're seeing is that the hot data that is that is most suited to go on that fast layer is often the metadata in the storage system for things like data reduction. In a software deduplication and a software compression where you have a log structured array, there is a lot of metadata for both mapping where the data actually is, as well as the hash dictionary for deduplication. That data is often accessed quite a bit, and so it fits very well onto the storage class memories. And so instead of actual customer data, having the metadata on the storage class memory that doesn't fit into DRAM can provide a significant acceleration for the total storage system. All right? Another important aspect of this is we talked about fitting into a hybrid cloud era is the ability to connect with the cloud. And so this device has the ability to connect with AWS as well as the IBM cloud. It's a 2U system. I talked about the 378 terabytes of usable storage and the full suite of storage services and the cloud connections. Remember when I first started, I said an important aspect of storage systems today is that they must be simple from the ground up. And this product has the hardware that is simple in having just 2 canisters with all of the electronics on it, with a mid-plane that has no active devices whatsoever, and then 24 flash core modules. So we call our SSDs flash core modules. Each controller, it's a dual-ported system. Each controller can talk to each of the flash core modules. It's active-active. It has the ability, each controller talks to each flash core module and can read and write, and there is a cache on both of the canisters. This device has 1.5 terabytes of cache. All right. All right. Now, as we started our journey of developing our own flash core modules, of our own SSDs, what we realized was that it was extremely important to really understand how that flash worked. So we developed a lab in Poughkeepsie, New York, and in Zurich, Switzerland, where we took the flash from Micron, Toshiba, Intel, many other places, and characterized it, and really understood how the flash worked and how it wore out. And what we were able to do by having this characterization lab is to develop some unique technology to help in 2 main areas of flash controller design. Number 1 is endurance, all right? Number 2 is performance, and there's a very close relationship. If I help the endurance by reducing the write amplification, I also help my performance, all right? And the important thing in the performance of a flash system is not just the benchmark performance, the headline numbers of how many IOPS you can get. What my customers care about even more than that is how consistent are you, all right? Is your performance consistent? Can I count on that 100,000 IOPS all the time? Or will your garbage collection get in the way and at times cause me latency spikes that I don't know why they happen, and now my customers from the databases and applications are calling me asking why they had a 1-second response time. We spend a lot of time in developing our technology to assure both high endurance, but more than that, consistent performance. So in our characterization lab, we put thousands of flash devices. Thousands of flash devices have given their lives for our technology advancement. We've been able to use flash knobs to extend performance, as well as endurance. In some ways, endurance has become a non-subject, all right? It's because the density is so high that we don't have to worry too much about the endurance. The thing that changes that is QLC, all right? As we work to make QLC ubiquitous in the data center as well as in consumer devices, endurance once again becomes an issue, and we have to make sure that we can provide the endurance as needed, but just as critical that we're going to be able to have the performance as we're providing that endurance. One of the technologies that we've been able to work by having a characterization is to reduce the write amplification. This has come out of our research lab. Here's an example of a technique that we use to determine which blocks to do garbage collection on. And some of the more common techniques, which is just a circular buffer, you just choose which blocks on a round robin basis. There's also greedy window, which just says I'm going to keep an accurate record of how much every block has in terms of invalidation. And I'm just going to choose the one that has the most invalidation and choose it. And then the technique that we have developed, NBin plus heat segregation. What we found is that in real workloads, we can be 2 to 3 times more effective in our, and have 2 to 3 times less write amplification. And if I have 2 to 3 times less write amplification than these other techniques, what that allows me to do is have more endurance, but more important, there's less garbage collection going on. And if I have less garbage collection going on, I can provide more consistent performance to my customers. So that's one example. This provides a summary of the technologies that we have inside our FlashCore modules. The thing that I am probably most proud of is our compression algorithm. We have high-speed compression that is a modified dynamic gzip algorithm. Modified dynamic simply means that we have multiple Huffman tables that we use, and the one that provides the best compressibility, that is the one that we will use for the compression of the data. The other thing about our compression algorithm is not just how it compresses data, but it gets back to what we talked about at the very beginning. The critical thing about a storage system is it can never go down. And so as we're compressing that data, we actually have a decompressor that's working alongside it. And that decompressor is decompressing the data as it goes and then doing a bit-by-bit compare to the actual data to make sure that nothing went wrong in the compression process, all right? And therefore, if there's anything wrong with the compressor, or there's any pattern that we just happen not to compress correctly, if there's anything in the FPGA, a soft error upset, we'll detect it and then just send the uncompressed data. And I can't tell you how much this has helped us. When we were first putting out the FlashCore module, we had a very intermittent timing problem, and one that was very difficult to find, and we were able to find it because we had this check on the data. We were able to see, the data is not comparing. So this is an example of when we're doing our design, it's not just about the performance, it's not just about having the compression, but it's the ability to check for errors and detect them on the fly. The other thing that we do in addition to the compressor is that we have an encryption algorithm that runs, of course, after the compression. So we have embedded encryption for data at rest. So the other key technologies that that we have inside the FlashCore module. One is our ECC algorithm. Most SSDs use a soft decision error code. And when we were looking at that, meaning that you might have to reread the data as the device ages to make decisions about how to correct it. Problem with that is that it hurts the consistency of the performance. It means that I may have to read a couple of times, and therefore, as the device ages, my read performance may go down. And we didn't want to do that. So as an example, we chose a hard decision algorithm, one that we've been very pleased with, and I never have to read the data a second time. We have developed something called health binning. And health binning is simply this. Let's imagine that we were tasked with the job of carrying a huge load up to the Golan Heights, all right? What we could do is just to take that huge load and divide it by the number of people in this room, and each person would have to carry that amount of load. That has been the algorithm that has been used for garbage collection in the past. I'll just use every block equally, all right? And my wear leveling is very symmetrical, all right? So we would divide this load, and let's say I was given 50 kilos that I had to carry. I would maybe make it out the door, and then I would fall over, all right? Instead, a better algorithm is to assess the health of each person in the room and determine the young dudes, the young people, and say, this gentleman over here, you're going to have 100 kilos, all right? Me, I get 5 grams to carry up to the Golan Heights, and therefore we take those that are weaker and give them a load that they're responsible for. Those that are stronger get a heavier load. That's exactly what we do in our flash controller. Because we characterize, we're actually able to project the health of each of the flash blocks. We can determine early on how each flash block is going to age, all right? And therefore, those flash blocks which are the healthiest, they are the ones that get used the most. And we put the data that is the hottest, that changes the most, in those flash blocks, which are the healthiest. Now, the flash blocks are the least healthy. We say, okay, that's all right. You're getting old. We're going to let you take the data that is least used. And the important thing to recognize in that is that all data has a skew to it. We often do performance based on random access, and in the real world, there's a skew. There's a 80-20 rule, and 20% of the data will change the most. And so we use that aspect then to in our health binning. And we have several other algorithms that we have developed that help us to provide our customers, number one, consistent performance. Number two, to give them not just consistent performance, but to give them data efficiency. And number three, and maybe most important, is to give them peace of mind and to detect errors and to protect them in case something goes wrong. All right. So if we summarize, let's go back to that first slide that I talked about. What is critical in this era of multi-cloud for storage developers? I think number one is to keep in mind that things do go wrong. And so as I develop protocols, as I develop new technologies, as I develop new storage systems, I have to think, what can I do in terms of AI, in terms of prediction, to help support and service this device without the customer having to do so? Second, it's how do I make it simpler? All right? Simple is a complex thing to design. How can we build the storage device so that It will be simple to use, simple to install, simple to service, and simple to maintain. Third, how do we differentiate our flash? How do we allow for new technologies to come in like storage class memories and accelerate the flash and to provide consistent performance all the time? And fourth, to realize this is an interconnected world with a hybrid cloud, and my storage system has to be able to connect with and send data in a fast, seamless fashion to the cloud. It's an exciting time to be in storage. And the interesting thing about that last statement is I've been saying it for 38 years. And never ceases to amaze me how things continue to change. And if anything, the change is starting to accelerate. And so I really encourage all of you to take advantage of today. I'm really impressed with the agenda that I see, the caliber of the talks you're going to have. So I appreciate your attention and your patience, and hope that you have a very good day learning more about storage in this complex world. Thank you very much.